Alright, YouTube, so this lecture is going to talk about finding molarity of solutions. So this can be a bit of a struggle sometimes for students that are in first semester general chemistry. Now this is a skill that you should carry throughout your science career, especially when you get to Gen Chem 2, and even in organic. You're going to need, if you want to find moles of a particular compound in solution, you need to be able to use molarity and concentration effectively. So molarity is one way of representing concentration of a solution. Now, there are other ways such as by weight or by volume, but molarity is by far the most common example that we come across, so it's very important to master. So, what is molarity? Molarity is a way of defining concentration of a solution where we calculate molarity, represented by big M, being equal to the moles of solute. Now, solute is whatever compound is being dissolved in the solution. Usually it's a solid, not always. And that is going to be over liters of solvent. Okay. And this concept leads to molarity. So if you can get moles of solute and divide that into liters of solvent, that is the molarity, the concentration of your solution. And that makes sense. We're really saying how much of a given compound do I have in a given amount of liquid or solvent. And that's a good representation of concentration. So let's solve, I've got two problems here I want to work through to help students in terms of understanding how we can manipulate this. It's really a pretty simple equation, but you want to make sure that you can utilize it in all different forms. So number one, what is the molarity of a solution where 23.8 grams of sodium chloride was dissolved in 822 milliliters of water? Now I just want to point out here, moles of solute, it's not grams of solute. We need to find moles of solute, and the volume of the solvent needs to be in liters when you're calculating molarity. It cannot be in milliliters. Now, don't confuse this with the dilution equation, which some of you may know, which is M1V1 equals M2V2, or some people call it MIVI equals MFVF, where I is initial and F is final. In that case, you can use milliliters for the volume units, but that's because molarity already has liters built in and it'll cancel with the other molarity. All right? So, when we get ready to do this, we would start with what we know. So we're going to find the molarity. That's what it wants us to find. And we know that that's going to be the moles of NaCl. Now we have grams at the moment, over the liters of water. Well, the liters of water is easy here. We have 822 milliliters of water. Keep in mind that milli is 1,000. So all I would need to do is take 822 divided by 1,000. And that's going to give me 0.822. You really want to get in a habit of starting to just automatically moving the decimal 3 places over, because milliliters and liters, they're both such common units, you're going to be constantly converting back and forth all the time. So it is a good idea to be able to start doing this in your head after a couple of attempts. So that's the volume. This is going to be in liters now because we converted it out of milliliters. So the remaining portion is to get the moles of sodium chloride. Now in order to do that, I can take the amount of sodium chloride, which was 23.8 grams of the NaCl, and then I'm going to utilize this to solve the moles. Now I need the molar mass from the periodic table in order to do that. So if I go to the periodic table, you would ideally want one in front of you if you're following along here, but you should have one if you're practicing these types of problems. Okay, I go on and I find that the sodium is 22.99. In my examples, you'll find I always take the molar masses out to 2 decimal points. And then I'm going to also need the chlorine, because it's NaCl, and the chlorine is 35.45. Okay, so I sum these up together and I find 58.44, and that's grams per mole. So that's the molar mass of sodium chloride. All right, so 58.44. Now remember, some students get confused as to where to place this. Grams should go on the bottom to cancel out grams. Okay, so of NaCl in every 1 mole of NaCl. And if I solve for this, I'll then have moles of NaCl. So when I run that through, you should get 0.407. Mind your significant figures. We started with 3, and so we're going to end up with 3. This is moles of NaCl. Now this is what I needed for the numerator in my molarity equation. So I can now combine these together to find molarity. I bring in the 0.407 moles of NaCl, and then I can also put on the bottom here my 0.822 liters, and that came from the water. So if I run this equation through and I do the arithmetic here, I find that 0.495 should be the molarity, again minding my significant figures, of the solution. Right? And that's how I would do a straightforward problem where I'm told the amount of solute and I'm told the amount of solvent, and I can find the molarity. Right? So let's take a look at an equation where we would have to sort of rearrange or manipulate the molarity essentials. So how much water would be required to create a 1.50 molarity solution with 75 grams of sodium chloride? So now they're telling me, hey, you have this much salt, and we want this concentration, right? I would like a 1.5 molarity as the concentration of that salt. So how much water would you as a chemist add to 75 grams of NaCl in order to make a 1.50 molarity solution? All right, so that's the question. So what I would do is I would say, all right, 1.50 is the target that I'm shooting for. And what I can find is the moles of NaCl here, right? And down here, this is what I need to solve for. The X, right? We're going to just keep X there. X is going to be the liters of H2O if I can solve through this problem. So again, to get moles of NaCl, just like I did above, I need to take the amount that's given. So they're telling me I can start with 75 grams of the NaCl. And then down here, I would use the same value again. Okay, so 58.44 grams of NaCl in every 1 mole of NaCl. So grams will cancel with grams. And then I find when I plug that in that I get 1.28 moles of NaCl. So that is what I can plug in right here, right? I can say that this is going to be 1.28 moles of NaCl. So for the sake of algebra, I'm just going to remove the units for a moment and say I have 1.50 equals 1.28 over x. So now I'm really just solving in an algebraic sense, right? So I can multiply both sides by x, and that will rearrange the equation to 1.5x equals 1.28. Okay. Now I want x by itself because x represents, remember, the liters of H2O. So if I can find x by itself, then I'm good to go. So now all I need to do is divide through by 1.50. So I'm going to divide through by the molarity. All right, and then I find that x, if I run this through and I do the arithmetic, is going to be 0.853. So what does that mean? It means that I would need 0.853 liters of water in order to accomplish this, or if you were asked for it in milliliters, it'd be 853 milliliters of water that you would need. And so if I add 853 milliliters of water to 75 grams of sodium chloride salt, I would end up with a solution that is 1.50 molarity. And again, I was minding my significant figures the entire way through this. We started with 3 and 3, and that means I end up with 3 when I do my answer. All right, so hopefully this starts to cover the topic and narrow the scope of how you could use molarity in order to find concentration of a solution. If you're given grams, liters, milliliters, it's really just manipulating these 3 potential unknowns. 2 of them should be known, 1 is unknown, and then you just solve for it algebraically. All right? So please remember to like, comment, and subscribe because that really helps the channel. And thank you so much for the support and taking the time to learn with us. And we will see you guys for future lectures. Thanks a lot.